we have studied the postulates of the Bohr's theory. Now we will study the applications of the Bohr's model and we will derive each of these factors mathematically. So let's start. So these are the applications of Bohr's model. First of all, we will find out the radius of a particular orbit. Radius of orbits. Now, the orbits are of different size. So, according to the distance from the nucleus, the radius of the orbits will change. So, each orbit will have a different radius. Okay. Now, the statement is the radii of the stationary states are expressed as Rn equal to n square a naught. Now, how did we get to this formula? Let's say now we will find out the radius of nth orbit. Okay. Radius of nth orbit. So, for the radius of nth orbit, what will be the centrifugal force acting on the electron in this orbit? It will be mv square by Rn, where Rn is the radius of the nth orbit. Okay. So, we know that these two forces equate each other. So, we know that the charge of electron is E and the charge of nucleus is Ze. So, we can write K E into Ze by Rn square equal to mv square by Rn. Now, Rn will cancel out. So, this becomes K Ze square by Rn equal to mv square. So, Rn will be equal to K Q1 Q2 by mv square, that is equal to K Ze square by mv square. Okay. Now, to find out radius, we know the value of K since it is a constant. We know Z. Z is the atomic number of the system that we are seeing. E is the charge of electron, m is the mass of electron and v is the velocity of electron. From this we know every value except v. So, we need to find out what is the expression for v. From the expression of angular momentum we had seen that mv square mvr equal to nh by 2 pi. So, we will write m vn rn equal to NH by 2 pi. This is Vn, okay. So Vn will be equal to NH by 2 pi mRn. So we will put the value of Vn in the expression of Rn. Putting the value of Vn in the equation, let's say this is equation 1. So we get Rn equal to k Ze square by m into, here we will put the value of Vn square, this is square. So what will be Vn square? Vn square will be n squared h squared by 4 pi squared m squared Rn square, right? So we will put this value here. Now if we arrange this in a better way, this will be okay. So m will cancel, 1 m will cancel and 1 Rn will cancel. So we get 1 equal to k Z square by n square h square into 4 pi square mRn. So we get the expression of Rn as n square h square by 4 pi square k Z square m. So this is the expression of radius. Now in this expression the value of h is constant. We know the value of k, we know the charge of electron and the mass of electron, and of course we know the 4 pi square. So we know h, these are known, k is known, e square and m are also known. So what depends on the systems? It is the n, that is the principal quantum number, and z, that is the system for which we are calculating. So we can reduce this as Rn equal to n square by z into h square 4 pi square k e square m, and we can write this expression as a naught. So we get Rn equal to n square by z into a naught. Now we have told earlier that Bohr's model was applicable for hydrogen atom. So for hydrogen atom, z equal to 1. That's why Bohr said Rn equal to n square into a naught. This is the expression of radius for hydrogen atom. But for others, it will be this formula, Rn equal to n square by z into a naught. Now the value of a naught is equal to 52.9 picometer or 52.9 into 10 to the power minus 12 meter, that is 5.29 10 to the power minus 11 meters. Okay. Now this value is known as the Bohr's radius. Why? Because Bohr's model was for hydrogen atom, and the hydrogen atom will have a radius of n square into a naught. Now for hydrogen has one electron. Okay, this will be in the first orbit, so n equal to 1, therefore RH will be equal to a naught, which is equal to 52.9 picometer. So this was known as the Bohr's radius. As the number of orbits increases, that is the principal quantum number increase, the radius will also increase. So Rn is directly proportional to n. Now the next is velocity of electron in nth orbit. Velocity of electron in nth orbit. Okay, how can we write this? We have mvn Rn is equal to nh by 2 pi, right? So Vn will be nh by 2 pi m Rn. Okay. Now we know the expression of radius that we have found out. This is the expression of radius. So now we will put this expression of radius in the expression of velocity. Let's say this is equation 2. So putting value of Rn in equation 2, what we will get? We will get, let's write expression for Rn once again. The expression of Rn was n squared h squared by 4 pi square mkz e square, right? So we will put this value here. Vn equal to nh by 2 pi m into n squared h squared by 4 pi squared m k z e square. If we write this in a better way, we get nh by 2 pi m into 4 pi squared m k z e squared by n squared h squared. So 1 nh will be cancelled, 1 2 pi is cancelled, m will be cancelled. So we get the velocity of Vn as 2 pi k z e square by nh. So this is the formula of velocity of electron in nth orbit. Now in this formula again, we know all the values except n and z. So we can write Vn as z by n into 2 pi k e square by h. Now this term has a value of 2.18 into 10 to the power 8 in centimeter per second. Okay, so this can also be written as 2.18 into 10 to the power 6 meter per second. So Vn will be equal to 2.18 into 10 to the power 8 into Z by N centimeter per second, or 2.18 into 10 to the power 6 into Z by N meter per second. So this is the formula for velocity of electron in an nth orbit. Now for hydrogen atom there is one electron. So for hydrogen atom Z equal to 1 and N equal to 1. Therefore, for hydrogen atom, the velocity of electron in the first orbit will be equal to 2.18 into 10 to the power 6 meter per second. Okay. Now, the third parameter is the orbital frequency. What is the orbital frequency? Orbital frequency is defined as the number of revolution made by the electron in 1 second is called the orbital frequency. Let's say this is F. So, what is the circumference of one orbit? Circumference of one orbit is equal to 2 pi Rn, right? So, if we relate distance to revolution or number of revolutions, if the distance is 2 pi Rn, the number of revolution is 1. That is, in one revolution, the electron completes a distance of 2 pi Rn. So, for unit distance, the number of revolution is 1 by 2 pi Rn. Now, what is the distance covered in unit time? Distance covered in, say, 1 second is equal to velocity, right? So, Vn equal to Vn by 2 pi Rn. This is the frequency, that is the orbital frequency. So, orbital frequency will be Vn by 2 pi Rn. We know the value of Vn and Rn, so we can calculate orbital frequency. So, we have studied about some applications of the Bohr's model. We will study about more applications and we will see the energy calculations in the next lecture. Thank you.